Today, our topic is to study about the rat and a simple visualization of the same. Okay, and what we will do in Visual State, we'll just upload a PDF, right? We will load the document. Okay, so we'll create a simple embeddings of that using a, I'm using OpenAI embeddings model here. We will split the document by a semantic chunker so that it can help some understanding of the document how they are split up. We will create an index in the Pinecone API key. We will create a simple vector retriever and self check. We'll create a simple index. Okay. And then we will try to fetch it for the our end use case. Okay. So let me go straight into the from the top and let me show you the document called today. So this is a simple PDF of the forecasting model. Right? This is a page of around it has contained around pages around 138 pages. Okay, so I'll start from the beginning. Okay, so here I am uploading a PDF load. I have uploaded a file path. Okay, and using the pages payload, I have again uploaded the pages. Okay, this is the load environment. From the env environment. I'm loading all my API keys. Let me know if this point is not clear. Right, I can create a separate video of how to load an open API keys and how to go around it. Okay. And then I have created from experimentation LangChain a semantic junker so that our text splitter is better. And for OpenAI embeddings, right, to create a vectorized format of the PDFs that we have loaded. Okay. Then using embeddings, I have created a OpenAI embeddings. I have loaded this model from OpenAI embedding. Okay. And for splitter, I have uploaded in time values into the semantic checker. So that semantic checker, whenever it splits our document, it splits on the basis of those embeddings that have been formed out. Okay. And then I have splitted those documents into multiple pages, and post that I have created 345 chunks. Okay. I'm not running this part of the code till here because as you can see, right, it takes a lot of time to run this part. Okay. So it's very simple, right? I think you can go step by step and upload any only PDF, right? It doesn't read that text images very well because it's a simple PDF. Okay. Now we can see, right, how many length of the documents have been created. So total 345, those 138 something pages have been split it into pages of 345. Here the chunk overlap or how the chunks sizes will be formed is automatically governed by the semantic junker. It automatically splits the document into a format so that it doesn't form very big chunk or very small chunk, and also maintain the overlapping as well. Okay. Then from I have created a Pinecone as well, and from Pinecone I have imported my API key. Okay, and the service plus spec, and here I have uploaded my Pinecone key. And then I in the Pinecone key, right? I'm creating a index name personal, and just to see here, right, whether I have already this index, yes or no. So this is showing I already have an index personal. So let me show you what does it mean. Okay. So if I go to the Pinecone, let me start Pinecone. Okay, I can go to the Pinecone. See, it already shows I have an index personal. So let's see delete it. See, now the index will be deleted. Okay, now if you will see, my index has been deleted. So when I check now the index, it should show false. It is showing false. Okay, so I already deleted the index, so there is no need to run this again. Okay, this is just to show what is my embedding length, right? So each embedding has a different length of the dimension. So this OpenAI embedding models, right? If I just want to check what is the size of my embedding, that is just into how many vectors format it splits into. It is 1536. Okay. So since I have already deleted my personal index, okay, I'll create my new index here. Okay, it will take some time. These are the standard format and standard set that we have to write it. Okay, so you can see now if I go again and refresh this, I'll see an index personal. See, my index has been created again. Okay, now I will from Lanchen Pinecone, I will import my Pinecone vector store, and in the vector store, I will save the index. Okay, in the personal index, I'll create the embeddings that we have created at the beginning of the project. So let me go to these embeddings, right? So these embeddings we will store again and to the and this is why we will run this. Okay. And on the vector store now, we will add the documents that we have created. Since we have already created a vector store, in this vector store, we need to add the documents that we have again added. Okay. So this will again take some bit of time because it will add all the 345 documents that have been broken from the PD. Okay. If I'll check now here, it will show me 0 because we are not having into the pinecone assets in the retriever of the pinecone. So once we run this, it will show you that and the pinecone we have added 345 vectors. Let me go ahead again here and let me refresh this again. And you will see that it is also has a 1536 dimension and we have added our documents here. So all the 1345 documents that we have added, it will be stored here. Okay. Now to just to check whether my retriever is working correctly or not, I'll just invoke my model and see it is showing. What is the retriever model? Okay, it is on the page 2, page 77, page 107, and again page number 2. Okay. Now this is a very raw format, right? Suppose you added a very big PDF and you want to retrieve it into a very good format, right? Then we have to do the chaining part. Okay. Then let me explain you how does the chaining work. Okay. So we will use a prompt template. Okay. And from the Langchain, we will do a retrieval IQ. Okay. And from the Langchain Google Journal, we will upload the chat Google generative AI. Okay. And this is my prompt. Okay. This is how I want to pass my context. My context is nothing but a question plus the documents. Okay. These will pass to the prompt template. Okay. Along with the instructions. Okay. That you have to precisely, concisely answer me. I'm using a Gemini 2.5 Flash model. Retriever we have already created above. And this is the chat. Okay. But this chat will do when we'll ask a question, right? Like what is Ariba model? Okay. It will pass to the retriever. Okay. And the retriever will fetch all the documents, the 345 document from the top. Okay. And then it will stuff it. It will arrange in a sequential order all those 345 documents. And those 345 documents will pass into the context. Okay. And those contexts along with the question, what is Ariba model, will be passed to this. And the LLM will read these instructions and will give us the final answer. This is nothing but just to make it much more structured. If I run this, it will show me what is my Ariba model in a structured form. Hit run. It has already done. Okay, it is saying what the Ariba model is just statistical model, primarily used for model. So in the below as well, it's exactly the same instead of above chaining of prompt template, retrieval IQ and chat in Google Generative AI. What we will use is we will use the maximum marginal reference. So it will search our question with the retriever on the certain maximum marginal relevance, and it will try to find much more relevance. It's a retriever property. Okay. In this document, you won't find much difference because our PDF is small and the answer is straightforward, right? But you can see some of the sources it has changed, and also the answer is much more relevant. Okay. So this is my query, and finally, what we are doing is we are storing our answer into a nice Word document. So this is document that it will show. Okay, I think it will not show here. So we will need to go here and maybe in Finder, and we can see. Yes, it will show me what is the Rima model answer and sources as well. This is about it. I will attach the document. I will attach the code. Let me know if you need anything more on this same document. Thank you.